right, this video is for A days for the Flex Friday, February 19th. We're going to pick up right where we left off, where we're going to be solving trig equations, and these are the ones where we use our calculator. So you want to make sure you have your calculator out and that it's in radian mode. When I go to solve number 3, I'm going to take the inverse sine of each side. And I get that theta equals the inverse sine of negative, I'm just going to write 0.25 because I know a quarter is negative 0.25. We're going to be skipping number 4, so I'm going to use this space over here. This is where I then draw my unit circle and I determine which quadrants must my answer be in. Well, where is sine, which is the y-coordinate negative? That happens in the bottom of my unit circle. So I know that I'm going to have a quadrant 3 and a quadrant 4 answer. So I go ahead and I use my calculator and I go to second sine negative 0.25 and I get negative 0.2527. Now I'm kind of tempted to go put that over here in quadrant 4, or does it go in 3? Well, it doesn't go in either. What that's telling us is that it's negative because it's going down. And it's negative 0.2527, and this is 0.2527. It doesn't really matter if it's positive or negative. All that matters is that the distance from the horizontal is 0.2527. And so in order to find my quadrant 3 and 4 answers, my quadrant 3 answer is 0.2527 away from pi. Remember, pi is right here, and it's headed towards 3 pi over 2. So it's getting larger. So this answer here is going to be pi plus 0.2527. So I'm going to put that in my calculator, pi plus 0.2527, and I get 3.3943. So that's one of my answers. And then over here, I am at 2 pi, and I'm going in the negative direction, so it's going to be 2 pi minus 0.2527. So my calculator, I type in 2 pi minus 0.2527, and I get 6.0305. That's a 0, by the way, not a 6. Hopefully you can tell that. 6.0305. So my two answers that I got were 3.3943 and 6.0305. And they're my quadrant 3 and quadrant 4 answers. All right, let's go down to our last type. These are like letter D up here above. When you had to factor in order to solve. And so let's do ones like letter D. So we're gonna write down a series of steps for these. I found that that is helpful, and I actually had started to write the steps. We'll kind of start fresh here, sorry about that. And our first step, whenever you're solving a quadratic, is to set the quadratic equal to 0. You have to do that to solve a quadratic. So for number 1, we're going to subtract 1 from each side, and we get 2 cosine squared of theta plus cosine of theta minus 1 equals 0. Our second step is we are going to let x equal cosine of theta. Now, sometimes it's going to be sine of theta or tangent of theta. For instance, in number 2, it would be sine instead of cosine. It just depends on what's in the original problem. So I'm going to let x equal cosine of theta. So when I do that, I'm going to let x equal cosine of theta and rewrite the problem and rewrite the quadratic. So I get 2x squared plus x minus 1 equals 0. My third step then is to factor. Now, the nice thing about this quadratic is that even though it has a leading coefficient that isn't just x squared, there's only one way to get 2x squared. The only factors of 2 are 2 and 1, so we're going to have 2x and x, and that will give me my 2x squared. The only way to get negative 1 is going to be positive 1 and negative 1, or negative 1 and positive 1, but it has to be a positive and a negative, and the only number to make 1 is 1 and 1. Now, I'm not sure which one it is. Is it plus 1 here and negative 1 here? Or should the negative go first? We have to check. If I check, I'm going to check my terms here. 2x times negative 1 gives me negative 2x. 1 times x gives me 1x. And when I add those together, I get negative 1x as my middle term. Well, if you look up above, we want it to be positive 1x, which means I need to switch my signs and make this negative and this positive. When I do that, my outer terms become plus 2x and my inner terms become negative 1x. And when I add them, I get the positive x in the middle right here that I wanted. Now, if you get the signs wrong, the whole rest of your problem will be wrong. You have to get your factoring correct. And really all you have to figure out is, since there's only one way to get 2x squared, 2x and x, and only one way to get 1 and 1, the only thing you're having to figure out is where does the plus and where does the minus go. All right, our fourth step is going to be to put cosine or sine or tangent back in. Now, don't put back in the wrong one. If it's a cosine problem and you accidentally put sine back in, all your answers will be wrong. So you've got to be really careful that when you substitute back in, that you put back in the correct one. So this would be 2 cosine of theta minus 1 times cosine of theta plus 1. All I did was substitute where x is, I put in cosine of theta. And now my fifth step is to solve each factor by setting them equal to 0. So let's do that. 2 times the cosine of theta minus 1 equals 0. And cosine of theta plus 1 equals 0. And we have two equations then to solve. Let's do the one on the left. Add 1 to each side, and I get 2 times the cosine of theta equals 1. Divide both sides by 2. Cosine of theta is a half. So theta is the inverse cosine of a half. So this is where I'm now going to go to my unit circle, and I'm going to look for where is my cosine, which is my x coordinate, a half. So on my unit circle, I have an x coordinate that's a half right here. I'm highlighting it. So I'm going to stick with blue. On the left, it's negative. Down here at 4 pi over 3, it's negative. Back here on the right at 5 pi over 3, it's positive. So my two answers where cosine is a half are pi over 3 and 5 pi over 3. Go ahead and erase that. Go back. So theta is pi over 3 and 5 pi over 3. Those are two of my answers. Then for this one, I'm going to subtract 1 from each side. Cosine of theta equals -1. So theta is the inverse cosine of -1. So I'm going to go to my unit circle and look for where is cosine, which is the x-coordinate, -1. Cosine is -1 right over here on the left of the unit circle at pi. It's the only place. So I can go back. Theta is equal to pi. And those are my 3 answers for that problem. Right, so let's go ahead and do number 2. I'm going to do it in a different color just because this is getting a little crowded here. My first step is to set it equal to 0. So I'm going to subtract the 1 and the sine of theta, and I would end up with 2 sine squared of theta minus sine of theta minus 1 equals 0 because I moved these two over to the left, so I subtracted them both. My second step is to let x equal sine of theta. So I'm going to rewrite this as 2x squared minus x minus 1 equals 0. Then I go to factor. The only way to make 2x squared is 2x and x. The only way to make -1 is 1 and 1. I'll start off with a plus and a minus, but I got to check it. This gives me -2x. This gives me positive 1x. When I add them up, I get -x. And that's what I wanted in the middle. I wanted -x. So those are my factors. My fourth step is to put cosine, sine, or tangent back in. I'm putting sine back in. So 2 sine of theta plus 1 and sine of theta minus 1. And then I'm going to take each of these factors and solve it. 2 sine of theta plus 1 equals 0 and sine of theta minus 1 equals 0. Going to subtract 1. 2 sine of theta equals -1. Divide by 2. Take the inverse. And then I've got to go to my unit circle and I need to look for where my y-coordinate is -1/2. So on my unit circle, I have a y-coordinate of -1/2. I see one right here, and I see one right here at 7 pi over 6 and 11 pi over 6. So I get that theta, whoops, had my eraser on. Let's put that back in. Theta equals 7 pi over 6 and 11 pi over 6. I know this is getting really tight here. Those two answers. And then my very last one, add 1 to each side. And I get sine of theta equals 1. So theta is the inverse sine of 1. So I look for where my y-coordinate is 1 on my unit circle. And the only place I see it is at the top right here at pi over 2. So my answer there is pi over 2. So those are my 3 answers.